This conference will now be recorded. This conference will now be recorded.
I think we have good participants. I'd request Dr. Pratima.
Priyanka, I think it's still 2-3 minutes to for like 12:30, so we should wait for another 2 or 3 minutes.
Yeah,
Perfect.
actually, Dr. Andra is going to join in 2 minutes. Please just wait for her to join.
Perfect.
So it's
Perfect.
3 minutes to 12:30.
Yeah.
Okay, so it's 12:30 already. So if everyone agrees, should we start?
Hello, everyone.
Yes, I think it's a good time to start.
Okay, so a very good afternoon to everyone, to our esteemed speakers, all the participants, SIE organizing committee members. Myself, Dr. Pratima Singh, I am privileged to be representing Society for Indoor Environment. Today, I'm working as assistant professor in Institute of Home Economics, University of Delhi. And it's my pleasure to welcome you all on behalf of Society for Indoor Environment, which you also know by the name of Society SIE, in today's live webinar on the theme Environment and COVID-19, with the sub-theme Air Quality in Urban Built Environment. These series of live webinars is one of the initiatives to carry forward the long-standing legacy of the SIE in knowledge dissemination and sharing on relevant issues related to environment. Since we all are aware about the challenges faced by us in these pandemic times, it becomes imperative to be well aware and have a proper insight on this subject of environment and COVID-19. As this pandemic has pushed us into maintaining social distancing and keeping ourselves indoors, it becomes all the more important to talk about air quality in built environment. With the overwhelming response we received from across the globe for the successful run of the previous webinars on environment and COVID-19, it's our delight to present before you the next gen webinar today. So before we start, I would like to request all the participants to keep yourself on mute mode and cameras off for better listening and to minimize during the session.
Hello?
Um,
Hello? Can you please mute your mic?
I request all the participants to please keep yourself. Yeah, I again request all the participants to please keep yourself in mute mode so that we minimize distractions during the session. And also, if you have any questions, you may ask them at the end of the session, or you may submit them in chat box, and we'll try to take them at the end of the session. With this, I'm profusely overjoyed to take the opportunity to introduce my SIE fellow members, Dr. Sunil Gulia, who is the organizer for today's event, and Dr. Chentila Sumant, who will be attending this webinar. Dr. Sunil Gulia is working as senior scientist in New Delhi Center, where he works in the field of air quality management and modeling. He did his PhD from IIT Delhi. Welcome, Dr. Gulia. And now coming to Dr. Chintala Sumant, he's working as assistant professor in the Department of Civil Engineering, NIT Warangal. He works in the area of air quality management, modeling, and indoor air quality. He has also pursued his master's and PhD degree from IIT Delhi. So it's a pleasure to have you both with us. So Dr. Sumant, without any further ado, over to you to moderate the session and introduce our esteemed speakers for today. Over to you, sir.
Thank you, Dr. Pratima, for introducing me, the distinguished speakers and participants. On behalf of SIE, I welcome one and all for this webinar series on environment and COVID-19, especially focused on air quality in urban built environment. Today, we are privileged to have two eminent speakers in our session. The first speaker is Professor Prashant, and the second speaker will be Dr. Anubha Goel. Firstly, I would like to introduce Professor Prashant. Professor Prashant is working as a professor and chair in air quality and health. He is the founding director of Global Center for Clean Air Research, GCARE, at the University of Surrey, United Kingdom. He is also working as an adjunct professor at Trinity College, Dublin, Ireland. His multidisciplinary research builds an understanding of the formation, emission, and exposure of particles, both from vehicular exhaust and non-vehicular sources. He investigates their contribution to pollution, especially in megacity contexts. He is developing approaches to low-cost sensing and contributing to the development of exposure control technology and guidelines for policymakers to curtail pollution exposure in cities with associated health benefits. He has supervised over 25 PhD and postdocs and has published more than 200 journal articles, attracting more than 6,550 citations with a H index of more than 45 and an IT index of more than 100, specifically to be 108. He's currently also working as a principal investigator for various projects uh, with NERC and EPSRC, Innovative UK, and H2020 operandum programs. Professor Prashant has also secured more than 6.4 million pounds research funding from RC UK and international bodies, and he is also serving as in the editorial board of several journals and reviews and advisors as a panel member for many funding agencies worldwide. He is convening Royal Society's rapid assistance in modeling the pandemic on COVID-19 currently. His research has been featured well in many media outlets such as the BBC and the Times. Professor Prashant, we are privileged to have you on board for today's session. So, with this introduction, I would like to hand over the session to you for your presentation, sir. Now, I request Professor Prashant to start his presentation.
Yeah, thank you, Suman, for your nice introduction. Sorry, I was on mute, so I was talking without realizing that it's been muted. So what I'm going to do today is I will talk a little bit about the pandemic, the COVID-19, and then also kind of give a little bit of an overview to how this kind of relate to the aerosols and the air pollution. So as Suman said, so I'm working at the University of Surrey. So I got my roots from India. So I did my master's from IIT Delhi and then PhD from University of Cambridge in the UK. It's my pleasure actually to connect with all of you, and thank you very much for the invitation. So what I'm going to talk in this presentation is just to give a little bit of overview in terms of my team at the Global Center for Clean Air Research here, and not going actually a lot of details in terms of what we're doing here, but just to give a brief kind of the overview of the research areas which we are kind of considering, which includes the air pollution control and looking into the air climate interactions. Then going back actually to the topic, which is more to do with the COVID-19 and the possible indoor transmission, and also talking a little bit about the impact on the air quality outdoors, of the COVID-19 lockdown. So, so just to introduce very briefly, so the GCAR, that stands for the Global Center for Clean Air Research. So this is a center which is based within the Department of Civil and Environmental Engineering at the University of Surrey. I've been working at the University of Surrey for almost around 11 years now. So after the initial kind of research for 6-7 years, then I thought of like founding this platform, which is a collaborative platform with a set up a vision actually as a clean air for all. The major kind of the emphasis of the work has been developing the solutions to the air pollution problems, to the climate change mitigation, and informing the policies, or kind of influencing the policies by the research, which is kind of providing the evidence base. There is a number of the areas we are working on. But more importantly, it's a very multidisciplinary kind of research. So we got projects which are going on at the moment, coming from the different funding agencies that include the Horizon 2020, UK, India. There is one very interesting project we are working on, which is called ASAP Delhi. So if you Google those words, you might be able to find actually the more information, and including some of the projects called Inhale. So this is like EPSRC looking into the interfaces of the air pollution with the health, and Operandum, which is looking into the nature-based solutions for climate change. So in general, the areas we are considering is looking into the particles, indoor, outdoor, mega cities, built environment, and the natural environment. And the kind of, the underpinning, the thought is to build the interfaces of the air pollution with the health of the public and the environment. So all the research somehow feeds into this the particular kind of the objectives which has been set up for the center. These are like two very quick examples in terms of what we are doing and how one can kind of allow introducing the research which can influence the policies. This was on the left, you can see there is a guidance document. So if you Google, you can find the copy, freely available copy of it. So this was almost the first ever guidance in terms of recommending how you can put the trees or the hedges around the roads to improve the air quality around the schools, or to improve the exposure, or to reduce the exposure of the people who are kind of, walking, cycling, and passing by. And on the right, you are seeing a very recent guidance documents which we have done for the schools, and the SIE is involved in it. So this will be coming into different languages. I'm sure that there will be a separate kind of a focus for when we get actually these in different languages, like in Hindi, Punjabi, and there are some other languages where the SIE and other collaborators are working. So globally, we are getting it around 10 to 11 languages. So there is work going on at the moment. So the idea is to disseminate actually to the the wider community as much as we can. So it is quite interesting document. If you're interested, you could even Google it and you can find the information about it. So let's go back to the original the kind of topic, which is the air pollution. And this is this figure basically showing you various sources. So if you ask that where this pollution is coming from, so there are a number of sources, which includes the natural sources, like the sea salt, or it could be the dust storms, or it could be basically the volcanic eruptions, or so on, depending on where you are. But then you got anthropogenic sources. So it's basically us who are kind of needing them for fulfilling our daily activities, and that need for the energy kind of driving it. So for example, the power plants, so you need to burn something in there, either it's a gas or it's a coal, and that produces the pollutants. The transport, waste management, household emissions, the agriculture sources. And the reason to show this slide is, like, you can also think actually though how many sources of these were kind of switched off during the lockdown or the ongoing lockdown, and how much were the operational, and how did this impact actually on the air quality in different cities. One of the things which remains is still a quite important contributor in terms of the air pollution, which is the road vehicles. It might not make actually a huge fraction of the total kind of the emissions, but when it comes to the exposure, then lots of people are around the roads or in these vehicles, what you're seeing on the road. That means that the exposure to the pollution is quite high. So this source is quite important when it comes to the air pollution and looking into the exposure. So if you try to kind of connect actually the threads and see actually how the COVID and air pollution could kind of the link with each other. So if you want to find actually the direct links, it's still in early phases whether there is a causal mechanism by which you can say that the air pollution is increasing or decreasing the COVID. However, there are some the understanding in terms of the when you inhale these pollutants, they are linked actually with the cardiovascular and the respiratory diseases. And there is also a very clear picture which is emerging all over the world, that the people who have got the existing the health problems, and they are catching the virus, then it is kind of ending up within the increased mortality. So to summarize, actually, if somebody is telling you the air pollution and the COVID, they are linked directly. So I think there is quite a lot actually to go in terms of understanding that relationship, which is kind of will be a very premature statement. But if you understand actually from the perspective of that people have been affected by the air pollution and having existing problems, and then they get the COVID, then they are more likely to have a much higher impact actually on their health as compared to a healthy person. So just to think about this, these viruses. So we everyone talks about these viruses, and sometimes it's also important to understand actually how big they are, and how they can disperse, or how they can kind of contaminate the people. So if you think from the perspective of the size, so on the x-axis here, I'm not sure you are seeing my cursor, but this is the size diameter, so which is starting with 0.01 nanometers to 1 nanometer to 10 nanometer and going up to 1 millimeter. And if you try to put actually the different different type of objects on this scale, you will see that, okay, if you think of the pollen, which you can see actually during this, during the summer sessions when you got a lot of these flowers. So this is almost around, you can think of around 400, 500 micrometer of size range. The red blood cells almost around, the 5 micrometer. But if you talk about this virus, so usually this virus, the range is less than 100 nanometers. So most of the viruses are less than 100 nanometer. So this is like this is kind of a COVID actually, where you're talking about a very small object. And if you try to put that into the perspective of how does this fit into, the particles, so which is considered as air pollutants, which is something called PM10. So these are the particles less than 10 micrometer in diameter. PM2.5, these are the particulate matters less than 2.5 micron, and PM1 is less than 1 micron. So you could see that this is kind of becomes a subset of these particles, what you are kind of encountering in in the environment when you consider from the size perspective. So just going a little bit further, actually, if you try to understand how big these virus sizes, if you try to compare it with the the commonly kind of understood things. For example, take a human hair, so like the hair we have. So usually the diameter of this hair is could be like 50 to 70 micrometer. And if you try to kind of put that in the perspective of the virus, which is almost 100 micrometer, so you could see that this is almost 700th time of the diameter of the human hair. So what we're talking about here is kind of invisible, the virus, or this invisible killer actually, which is around, but we can't really see from naked eye because of its size itself. So so this is the story in terms of how these viruses and the particle sizes relate to each other. Now, if you go further actually and try to understand what's happening with these viruses and how these viruses are being kind of contaminating the people. So one of the basic things you need to understand is that this virus is not really roaming around in the air freely and naked, because the size of the virus is less than 100 nanometer, but this is not really its actual size. So this basically is sitting in the saliva. The saliva is kind of providing, it's like a protection, the liquid under which it's kind of surviving. When it comes out of your mouth, so what you can expect is that the saliva has got the little droplet. Just think that when you're sneezing, so you can see a lot of these these droplets coming out. So you will have some bigger droplets. And those bigger droplets will fall close to the ground. And you might have heard actually that there is the rule of that you have to be at least 2 meters away or 1.1 meter away and so on. So these rules are quite different in different countries. So for example, UK and US, we here have around 2 meter rule. WHO recommends around 1 meter. But some of the underlying kind of thinking is that when somebody is sneezing or coughing, these droplets will fall within that particular range. So if somebody is in nearby, this will not really contaminate. But then when you're sneezing, there are also the droplets actually which are of very small size. So they could remain suspended in air and can perhaps increase the risk of infection. So what you really see is that you got, let's say, a droplet, which could be a bigger size of droplet, like you're seeing this picture here on the screen, and then you can have a lot of these viruses inside it. So one of the beauty of this virus is that it can mutate itself. So in a way that it can make its own copies when it's in the system, and you can see this liquid actually, which is kind of presenting it a food or a kind of a medium under which it can survive. So that's what, when it's in the body, it can survive for much longer. But when this thing is on outside, so for example, if somebody is infected and it's kind of sneezing, and this virus just go onto the surfaces, so this liquid, the layer will kind of broke, And when it breaks, actually, so the virus, the protection starts getting weaker. And that's what you see, that when people say that on different surfaces, it can survive up to around 3 days. So this is where actually the underlying thinking is coming from. So what happens when these droplets are coming? So these droplets includes water, salt, organic material, which is basically in our body. So, and when you're expiring, then some of these water contents evaporates, so the sizes becomes different, the smaller. So this is why you see the sizes could vary quite substantially. So this was basically a very brief story in terms of how these the size of the viruses is, where they are surviving, and how they can kind of transmit with each other. Now, one of the things which has been quite common, proposed by the WHO and a lot of these, the governments, especially in some countries like China, Spain, and now very recently in the UK, they made it almost mandatory to wear face coverings in the public transport or in the places where there are people with high density. So the reason is that, as you can see from this screen here, that if somebody is sneezing, and if you got a protection, so you are kind of protecting yourself. But if you don't have the mask, actually, then you might get actually the higher exposure there. But then there is a difference, in the situations. So, for example, sometimes people confuse actually whether they're wearing mask actually for the air pollution, or they are wearing mask for the COVID-19. Now, the mask could remain the same depending on what you're wearing, but your selection or your choice in terms of when you wear it could differ. So, for example, if you're going in a park, actually, you really don't need to wear a mask. The fact is that the air is so diluted there, unless you got people around you, that you will not get an infection from the air. But if you are in a public transport, or you are in a restaurant, or you are at a place actually where you are getting a lot of these the people there, then you got a high probability of getting infected if you are not having those protection. Now, there is another side of it, is that sometimes people wear masks and they don't handle it properly. So that becomes another problem, because if you can see from this, from this schematic, that some of those particles which are infected, which may be infected by virus, could deposit on the surfaces of these masks. And if you are touching it with with your hand, or you are putting it somewhere which is touching some other surfaces, that means there is a risk of kind of the cross contamination. That's what it's important in a way, that how do you dispose them, or how you handle your mask, or how you wear them, not really having touching actually the actual surfaces and so on. So this is kind of a two-sided sword, in terms of it can save you from one side, but it can also infect you, or unknowingly, basically, if you don't handle it properly. So when it comes to the COVID-19, we all know that the social distancing, self-isolation, hand washing, provision of hand sanitizers, frequent disinfection of the surfaces. So these are kind of the face mask. These are becoming kind of the norm, actually, which has really reduced the spread of the COVID-19. Now, the fact is that one of the things which has not really been understood and not got actually a lot of attention is in terms of the airborne transmission. So if you look at these masks, actually, so this figure is on the bottom, is showing the diameter range, which starts from 1 nanometers and going up to 1000 nanometers. On the y-axis, you are seeing the dn by d log dp, which is the distribution. And the red area is showing that how much mask actually has protected, or how much mask has kind of stopped these particles to go on. So the efficacy of the mask actually reduces usually for the smaller size ranges. So you can see a bigger red area when you go into the bigger size range. So in a way, if the particles are very small, they can still penetrate through the mask. So the masks are not really the foolproof when it comes to protecting from things. But if it comes to the COVID-19, because the virus is not naked and it might have some saliva or some liquid around it, so you are going into this range actually where you got a much higher protection. So one of the bits as I mentioned, is that it has not been really got a lot of attention is the airborne transmission. So the airborne transmission is going back actually to the last the point I made, is that when when these sneezes or coughing is coming, you might end up with a very small particles. So those small particles can remain suspended in air. And when they are in air, that means that if somebody comes in contact, then they might get contaminated. So one of the things actually which has been kind of emphasized quite heavily is the ventilation. So if you are at a place where there are lots of people, I think it's very important actually to have ventilation, and the ventilation strategies are such that the people are not really coming in contact with the fumes or with the kind of the droplets which are coming from one person. So you can see here one example. If somebody is kind of having infected and there are loads of these things, you could have basically the windows open. You can have actually some forced ventilation which can take actually these things. And if you have the recirculation, that could be a problem in this particular case, because you might have these particles coming in and going back again and spreading it all around. So if this recirculation is in place, then it's important that you might need to think of the filtration system in place in there. So this is an area where you can do, or you can talk actually a lot more about it. So I'm not going to go into detail, but just jump on to the outdoor air pollution. So what is happening into when the COVID lockdown was there? So what happened to the air quality? So I think many of the cities, if you might remember, or you still might see actually, seen the blue sky almost for the first time. So you can see the environment was clear, and that's kind of an indication of that particle loading is reducing into the environment. So one of the things is obvious, that when you switch off the sources like the industries or the the emissions from the vehicles, you are going to get actually the reductions. But another important thing is that how much reduction was there. So this is a work actually which is under review at the moment, where we try to look into different cities around the world and try to understand actually what's going on in there during the different lockdowns. So the lockdown periods were different. So you could see there is scale here, which starts from 0 and going up to almost 60%. So when we kind of spread it over the map, you can see here, you find that some of the cities are getting very high reductions. And the Delhi is one of them actually, which is almost got over 50% of the reduction. And some of them has got a relatively less reduction. But these reductions were related with a number of things. That relates to the number of sources in a particular area. It relates to what is in the surroundings. So for example, if you have got a lot of industries, small scale industries or the power plants which are still operating around these the cities, you might get actually some some impact from them. At the same time, there is a meteorological conditions which makes actually a huge difference. So let's say in one case we saw that in New York the reduction was really very minimal, almost few percent. And the reason was that there was quite a lot of the impact of the rain. So the rain actually could take away some of those things through the wet deposition as well. So if you try to kind of put that into a simple pictorial way, and in this work we were mainly focusing on the Indian cities where we considered Mumbai, Kolkata, Hyderabad, Chennai, and Delhi, and you can see actually the reduction. This is the percentage reduction, and that was quite high actually for Delhi. And it's not so well actually going for Mumbai, and so it's kind of the varying depending on the cities, depending on how much the other sources are kind of operating. But this gives a very good idea in terms of that even if you have the switch off experiment, this allows basically to still understand that there are still loads of sources operational. So if you look at a very opportunistic picture, we are only seeing like 50% reduction in Delhi's, the PM2.5 concentrations. That means that still 50% is there. So there are other sources which are operational, and those sources could make a huge difference. So there was some interesting kind of a very casual relationship we try to understand. So we see that what is the difference in the particle reduction during the lockdown, period. So this is basically looking at the lockdown period in 2020 and then comparing and minus the lockdown, the similar period in 2019. So what you see is this concentration reduction on the y-axis, and then on the x-axis here you got the traffic population. So each city has a population in there. So one of the interesting things was it shows almost a kind of a linear decrease. So you could see that the reduction is giving quite good kind of a correlation. Of course, it's a very kind of a the casual relationship, but it kind of indicates one thing for sure is that the traffic has a significant impact. And depending on the how much traffic each city is having, so for example, Delhi has a almost 10 million as compared to, let's say, Kolkata, which has got a much less than 2 million. The reduction was higher actually for these cities where you got actually there was a the traffic volume was high, but at the same time there was some outlier. For example, Mumbai, and it was interesting actually to think in terms of the what sources are operational, in Mumbai. And it's also kind of, I think, a city which is heavily served by the metro. So the traffic volume is also low. So there were some kind of, the interesting things which came around. So if you are interested actually to know more about it, hopefully this paper will be out in few weeks' time. So this will give you more kind of, the insight. Now, what we were doing is like I've been part of this rapid action modeling framework, which is sort of by the Royal Academy of Engineering. So I've been looking into the COVID-19 and what could we do actually as engineers to help kind of contain it. So we looked into different strategies. So there is a paper here which was published a couple of weeks ago. You could hear there. So the thing is that it's not really something that you can contain it by yourself. So there is a need actually for bringing in different sectors. So the first thing is the government. For the governments actually to make the decisions, I think one of the most important thing is the building the knowledge base. If you don't have this knowledge base, the problem is that you might take the decisions which are not in the right interest of the public and the economy, and they could be more of an inconvenience than really making a difference. And one of the things you might have heard about is the odd even trial actually, which was going on in Delhi for some time, and we had an assessment. Sunil was part of this this paper we did, and there were bits actually which you can easily see that they are not really making a huge the improvement when you compare it with the inconvenience and the other problems actually you're creating. So important thing sometimes is the building this knowledge base, and the European countries, the US, and a lot of these countries actually they are very active. So like this rapid assessment task force has been set up by the governments. The people are working, try to build the evidences, and based on the evidences, then try to take the decision. The another important thing is the built space, which is the improving the ventilation, especially the places where you got lots of people, so that the cross-contamination could be avoided. And this is one of the reasons why we are all sitting in our houses and not going to the offices these days, because the conventional system, they might not allow you to provide actually the level of ventilation when you need during that during the time when the occupancy is higher. But at the same time, it also might need actually thinking in terms of the ventilation. So, but then there are bigger challenges in that particular area, and there are still not certain answers for it. So, for example, what's going to happen when we have the winters? So we are talking about the ventilation where you can open the windows, you can open the doors and so on, which can allow to do something actually, but what will happen in the winters and the summers? The same thing with the public, so thinking about the individuals from the infection and so on. So it's our responsibility as well in terms of thinking if we have the issues of the infection, then we don't go into the public places and so on. So this is a paper where you can read more. So I'm not going into the detail, but if you're interested, I can send you the copy, but you can line it. And this just came yesterday itself, where we're talking about prioritizing the indoor air quality in the building design for the viral outbreaks. So I think I took more time actually, which I was allocated, and I really apologize for that. But with this slide, I would like to thank actually everyone who has been involved as part of my team, and collaborators and the supporters and so on. So thank you very much for your time and patience. I would stop here.
I'll request Dr. Sunil to please take over.
Hello.
Yes, Sunil, you are audible.
Yeah, thank you. Thank you, Prashant sir, for such a nice and wonderful presentation, which is very informative. And you have discussed many things in some such a short time. The cocktail of COVID-19 and air pollution and the challenge.
Sorry, I can't hear you. Maybe is this me or?
Sorry. Can you hear me, sir? Yep. Hello. Hello.
Yes, you are
you are
audible.
now.
Yeah. Thank you, sir, for such a nice presentation in such a short time. The cocktail of COVID-19 and air pollution and the challenges associated with the related issues are to be addressed urgently. We also thank you for your initiative on the development of the booklet of schools to protect our younger generations from the high-risk causing air pollutants. Thank you, sir, for the detailed explanation on the pathway of pollutant transfer. On behalf of SIE, we thank you for your informative and excellent presentation. Dear participant, we will take the question at the end. You just note down your questions in the chat box, and we will take it after the lecture of Dr. Anubha Goel. And sir, thank you so much. Just keep online so that we can have a question in the end. And thank you, sir. Now I'm making Dr. Anubha Goel as a presenter.
Okay.
Yeah.
Okay, so I'll share my.
Just a minute.
Okay, sure.
Dr. Goel,
So,
Dr.
Dr. Anubha Goel is a leading researcher in indoor environment quality management, leading to healthy buildings in sustainable built environment. She received leadership award at the ACIEQ 2019. Dr. Goel has been a faculty member at IIT Kanpur since 2010. Post 2 years of environmental consulting experience in USA. Am I audible?
Yes.
Yes, thank you. She is a graduate of GB Pant University, IIT Kanpur, and did her PhD in USA on spatial and temporal variations in occurrence and behavior of pollutants in the atmosphere. Her research involves both on field and in laboratory studies. That's very nice, and has led to several publications on emissions from indoor combustion sources and quantification of health impacts. Currently, research is underway in examining factors structural and behavioral influencing indoor air quality and how interventions can influence occupants' perceptions towards acceptance of an indoor microenvironment. Thank you, ma'am, for such a having a vast experience. And we are now inviting you to present your talk on the ventilation of indoor microenvironment is a key parameter to maintain quality of air in healthy building. Welcome, ma'am, once again.
Thank you. Thank you very much. Am I audible to everybody?
Yes, ma'am.
Okay. A very good afternoon to the people in India and a good morning or a good evening to the people in the other parts of the world. I am very grateful to SIE for this opportunity to be sharing my knowledge on this concept of ventilation and how it is an important parameter that actually can be contributing quite significantly towards the achievement of healthy buildings. Dr. Prashant Kumar has already laid out the path for my talk very well, and he has also hinted that ventilation is an important aspect. I'll take it from there and continue. Where he talked about the outdoors more, I'll be talking primarily about the indoor part. This gives you a brief overview of my content of my talk. I'll be starting with giving you an overview of the concept of IAQ, that is indoor air quality, as well as how it is linked to health. Then I'll move on to talking about the concept of ventilation. Then moving on to see that what are the outcomes that can be occurring if the required ventilation parameters or the required ventilation amount is not met inside buildings. Then we'll look have a brief overview of the concept of the healthy building network or movement, and then we will see that what we can do to be attaining the goal of achieving healthy buildings and a healthy built environment. To get things started, what do we mean by indoor environmental quality? Indoor environmental quality basically refers to the materials or the different aspects in a person's environment that are considered with respect to the person's health as well as the well-being of the humans as a whole. I think I will do. I'm sorry, I was trying to see this. Okay. As the screen shows, IEQ has several different components. It is composed of air quality, it is composed of your thermal comfort, and also lighting, sound, odor, and vibrations. They all are integral parts of your environmental quality. Of these, I will be focusing, as I mentioned, on the concept of air quality primarily. And it has to be remembered that better environmental quality is a key parameter to determining or working towards the achievement of a green building. The people who are organizing the meeting, I just wanted to ask one thing. On my screen, it is actually covering, half of the screen is covered by the blocks from the meeting on the right hand side. Is there some way I can remove them from there and not leave the meeting? I'm sorry to interrupt the flow of the meeting in this way.
It's showing half black.
No, it's not showing half black. I'm seeing the small boxes from the go-to screen. I actually can see that how my screen must be showing on your screen.
Okay.
Ma'am, you have to
No,
just go
it's
to the
view.
yeah, you have to just go to your presentation view. You might have been open to view everyone maybe, because of that it is happening.
But
There must be in the top.
your slide is visible.
Yeah, it's visible to you, but I'm able to see only half of it myself.
Okay. So you have to go to the view. You make it 50% or more.
Okay, I guess I'll just continue like that. It'll take up a long time for me to be doing that. Should I say I'm going to view everyone and should I say hide everyone? Will that help?
Yeah, ma'am. Go ahead.
Okay, one box is gone. Okay, thank you. So moving on, as I mentioned, that indoor air quality is an important part of the indoor environmental quality, and it is integral towards the achievement of the green buildings. So what do we mean by green buildings, and how are they important, and what actually constitutes a green building? We can say that a green building will be having all of these aspects that are listed in the third building that is shown on the diagram on the page. It actually comprises, it has to be having, it has to be healthy, and it has to be durable. It has to be having efficient water requirements maintained and met for the people, and it has to be a sustainable community. It has to be meeting all of those requirements. And the green buildings, they aim to improve the human health through design of healthy indoor environments. So moving on, what do we mean about, let's move on towards the concept of the indoor air quality. Indoor air quality, well, the quality of the air that you have in the indoor micro environment that you actually are occupying at the present time. This primarily includes your school areas, your homes, offices, where we actually end up spending more than 85 to 90% of our times these days. That becomes very important because the quality of the environment that you have is integral to good health. It has been found that the indoor air quality might have the levels of pollutants that is up to 2 to 5 times higher than what is actually present in the outdoor air. This actually is a way to say that outdoor air, when you're saying open the windows and let the air in, that does not imply that the air that you are bringing in is cleaner than the air inside. It might actually be much more contaminated and might be increasing the level of pollutants indoors. The second thing I would like you guys to notice is what are the major pollutants that we are concerned about in the indoor microenvironments. Well, starting from the left, you primarily have a lot of airborne particles. These airborne particles, primarily your coarse particles, might be coming from the outside. You might have the activity of dusting and cleaning up your floors or whatever. Those will be their indoor sources of the particles. Then you have the concept of indoor formaldehyde. This will be the pollutants that will be coming out from the emissions from the building paints and the other materials present in the different things that can be present inside the houses. You also have the presence of household colors and other stuff that is part of the material that we are using. Ozone. We have two types of ozone. Stratospheric ozone is good. It keeps us safe from the UV light, but the ground level ozone is not a good thing. And it will primarily be more of a concern in those areas where you have a lot of vehicular activity. Then the last thing is carbon dioxide. I would like to clarify here that carbon dioxide by itself would not be considered as a pollutant, but it is listed here because the levels of carbon dioxide are crossing a particular threshold. It can be leading towards the environment that is not good for health. And that brings in the concept of a sick building syndrome, which we'll be looking at afterwards. So why is it all of this important and why should we be concerned? Well, because if you are being exposed to these pollutants in levels that are not good for your health, you will be exposed, you will be, there's a pretty good chance that you will be acquiring a lot of health problems. And primarily, you can be having COPD, you can be having stroke and the other problems. And roughly 4.3 million deaths are caused every year because of indoor air pollution. If I remember correctly, last year or the year before last, there was a report that came out that is listing indoor air pollution as a bigger threat to human health than the cigarette smoking per se. And human indoor environmental quality, indoor air is causing more deaths worldwide, especially in India, than your outdoor air pollution. This slide shows you that what are the guidelines that have been stated in terms of the indoor air quality. Well, like we have air quality standards for the ambient air. PM10 should not be more than this at this location and stuff. In India, so far, we do not have any indoor air quality standards. The work is on the, continuing on that, but because of the lack of efficient, adequate amount of data, the standards have not been formulated officially so far. So for that purpose, I have listed the WHO guidelines, and this actually shows you that there are guidelines for the yearly, annual average values, as well as for 24-hour or 8-hour averages. The indoor air quality, if it exceeds these levels, then it is going to be a case of threat to human health. One thing we probably should be noticing that these are WHO guidelines, and this the values that are noted here probably would not even be meeting the background levels in the Indian conditions. That is why even our outdoor air quality standards are on the higher side, higher than what is being prescribed by WHO. But this in general gives you an idea of what is good for your health and what is otherwise. The second table actually shows you the levels of the indoor met parameters that have to be considered important to be maintaining a healthy environment. This includes your temperature, relative humidity, as well as your ventilation. The ventilation in terms of fresh air and ventilation can be expressed in terms of CO2 as well. So CO2 can be used as a surrogate to see how good the ventilation in a room is, and this is going to be subject to the activities that you are performing. If you are cooking, then probably some CO2 is being released. If there are too many people in the room, the CO2 levels will definitely be high, and you require to be having more efficient ventilation conditions. This gives you an idea about what are the different sources of indoor pollutants. By this diagram over here, I just want to show you that different microenvironments inside a house, your office, your bathroom, your kitchen, whatever, they will be either having appliances or activities will be occurring there that will result in the release of different pollutants. that will also result in the release of more humidity that will lead towards the development and existence of more molds inside the houses if the ventilation conditions are not maintained. And primarily, as it's stated at the bottom of the screen, the toxic products primarily and the inadequate ventilation, this high temperature and humidity are a few of the parameters or causes that lead to indoor air pollution inside homes. This is a graph that I have picked up. I found it quite interesting to show you the increase in the number of deaths worldwide because of indoor air pollution. They are comparing the data they have from the year 1999 and the year 2017. What I want you to notice from here, that on the higher side, roughly 10,000 deaths, sorry, 100,000 deaths occurring every year. The top on the chart is actually China, and then there is Pakistan. So they basically to show you that in the Asian region, the deaths of the people because of indoor air quality is much higher than in the other parts of the world per se. I tried to look for India in this figure. I was not able to locate myself, but I'm sure that India is mentioned somewhere in the middle part over there somewhere. From here, this graph actually shows you the share of the deaths from indoor air pollution worldwide in the year 2017. The interesting thing to notice here is that out of the different countries, India stands at the level that 10% of the deaths that are caused here annually, they are attributable to indoor air pollution. With the increase in the time that we are spending in the indoor environment, more sedentary lifestyles, and the building construction be such as to be mitigating or minimizing the exposure or permission of the outdoor air to be entering indoors, the percentage is more likely to be going up. Moving on to the concept of ventilation. How do we come to this point? We say that basically, as you have seen so far, indoor air pollution is a big concern. It is causing a big threat to human health. And one of the things that most people and researchers are beginning to say, that increasing ventilation and good ventilation of the system or buildings is an important aspect to be maintaining your indoor air quality. Or in other terms, ventilation acts as a surrogate to indoor air quality. In other words, the better ventilation system you have, the better air quality you can be expecting. The word ventilation derives from the word in original English word vent, which actually means a small opening that allows air, smoke, or gas to enter or leave a closed space. And there are basically two functions the process of ventilation is achieving. Firstly, it is providing the air for breathing. In a closed room, no air permitted to enter or leave, then survival might be one of the biggest concerns that we'll have to face. And the second thing is, it is providing the fresh air to maintain indoor air quality. Again, here I'll point out that the term fresh is should be considered very, very seriously. You might be permitting the air from the outside to be coming in. It might not necessarily be cleaner than the air you have inside. And as you'll be seeing towards the end of this talk, that ventilation is increasing ventilation is not the only solution to be ensuring good air quality, right? There's or other by this small sorry by this small oh, I'm sorry, this one. This slide actually shows you the importance of ventilation both in the winter and the summertime. In the summertime, you have to ensure that what happens is the heat that is being generated, it reaches the topmost part, light air, it rises to the top. And if you have proper ventilation conditions, like in the older houses we used to have, there would always be an opening at the top of your wall. And the walls used to be quite high. Not like today that we have 10 to 15 high story level building. Earlier it used to be 20 to 30 feet maybe, something like that. So the hot air would be on the top and it would be given area to be able to go out. That would be maintaining the indoor environment. In the winter time, if you have proper ventilation, there is not going to be the accumulation of the condensation of water vapor. The molds will be less and there's going to be less problem with the increased relative humidity in your house. So this is basically to highlight that in different weather conditions, you need to be having proper ventilation to be ensuring that the indoor air quality is maintained. This small graph over here is just to show you the difference between the passive and the active modes of ventilation. The passive mode of ventilation is pretty much you are not using any fans or anything to be ensuring that there is a flow of air in your room or your home or wherever you are. The air is flowing all by natural systems. You can be having one window, two windows, or you can actually be having stacked ventilation also. The other option is you can be providing small fans, some small measures where the air is actually rising to the top of the building or some other mechanism, and there is a proper exchange of air that is occurring. With this, we move on to be looking at the major outcomes that can be expected when there is a reduction in the amount of ventilation that needs to be provided. I decided to include this small graph over here to give you an idea that what are the different agencies that are responsible for ensuring ventilation conditions, for providing us guidelines about what ventilation conditions we should be having. So here is the Bureau of Indian Standards. You have National Building Code and the ASHRAE, which is the organization which is followed the most. It is interesting to see that the different locations inside a house or an office or wherever will be requiring different kinds of air exchange rate. ACH pretty much means how many times you are having the exchange of air, the air supply within the location or the micro environment per hour. So in the kitchen, you require at least 6 times. In other areas, it is not mentioned that clearly, but this is the BIS listing. So pretty much this means that you cannot be designing a building just by using one level value of ACPH for the entire house. You might actually need to be considering the air exchange rate at different levels in the different macro environments that you are considering. One of the major problems we end up seeing because of the lack of adequate ventilation is the occurrence of the sick building syndrome. Sick building syndrome, as the name suggests, the building is sick. And you are actually, either the building is sick, there is too much of air pollution inside, or when you are inside the building, you actually feel quite sick. You might be having a headache, you might be having other health problems, and that has to be rectified and taken care of. And this is basically, this actually shows you that the inadequate ventilation can increase the indoor pollution levels by not permitting the indoor pollutants to go out. It is not able to bring in enough air to be diluting the pollutant levels, and it is not able to carry out those pollutants. So in a nutshell, you are having the accumulation of the pollutant levels inside the buildings, and people are beginning to feel sick. CO2 concentrations have been shown to have a high linear variation with sick building syndrome. That is why earlier I had mentioned CO2 can be listed as a surrogate for the sick building syndrome that we have seen. And actually, we did a survey in our Can you guys see me?
No, ma'am, your screen is showing black.
Okay, so I think I'll go back to my slide. And can you guys see my screen now?
Yes.
Okay.
Maybe you want to try making it fully screen, so you just try
yes,
it fully.
Yes, Prashant, I'm trying to do that. I just got to this. I'm going to do the slide share now. I think, let me see.
Is there on the bottom? No, just do the fully screen button. There should be a fully screen button on the bottom.
It is showing 65.
No, go down. You know where you have written your. No, not this. If you look at the volume button, there is a little button on the side.
I was seeing that earlier, but I'm not seeing it right now.
Okay, no, okay. Anyway,
I can't see the slide share button, full screen button. I'm not able to see.
Ma'am, you can press the F5 button.
F5 button. Achha. Okay. See, it's coming black now. I don't know why.
Dr. Phil, probably you can just speak about the study that you were mentioning that you've done, and our attendees will be able to gain from that, if not a slide.
Okay, so I was basically mentioning that we did this study in several office buildings, office rooms in IIT Kanpur, and we also tried to do a study in the library on our campus during the exam time. My student is doing his master's on that, and we're working on the paper. But the results actually show that during the exam time, the number of students was so high in the library that the CO2 levels were actually exceeding the OK level of actually 1,000 ppm. The students, we did try to do a questionnaire survey, trying to see what the students' perception of the quality inside the library was and how they were feeling about it. Most of the students were actually complaining, and they were saying, "I feel a headache, I feel very drowsy, I feel sleepy, I'm not able to focus on my work." So all of those are the symptoms of a sick building syndrome. Conversely, when they were doing it in the regular time, when the regular classes were on, there was no problem and the things were pretty much within control and the CO2 levels were quite low. So this actually shows you that where there are the occupant level inside the buildings is high, the CO2 levels have to be watched carefully, and they can actually be indicating the sick building syndrome. Should I go back? I don't know how to proceed. I'm not able to see the slide share button on my screen, so I'm not able to share the slide per se. Should I just be showing the slides like this? It's going to be too small.
No, it's
absolutely
visible.
Okay, you can go with that. Yeah.
Should I continue like this only?
Yes,
Yeah.
please.
Okay. I think my it's getting hung up on me. Please give me a second. I'll actually turn off the Zoom PowerPoint, and I'll try to turn on my. I'm really sorry about this. My screen is stuck. Is it possible to share my? Let me just see if I can be pulling up my. Can you guys see my slides now?
Yes, ma'am.
Yes, yes.
I apologize. I don't know why this is happening. I'll try to go a bit fast and make seconds slow, I guess. Okay, so we were looking at the concept of the sick building syndrome, and this has been found to be quite a problem in many areas. And the basic causes is, again, there is inadequate ventilation, and there can also be some chemical pollutants. They are coming airborne chemical pollutants. They are causing this problem. And the different kinds of health impacts that people can be complaining about are listed on the right-hand side. And this feeling of ill health can lead towards the increased sickness and absenteeism, both in schools as well as at workplaces. And this can actually decrease the productivity of the workforce also. There is a lot of research happening and a lot of papers are coming out on this. And several work is actually being done by the School of Public Health at Harvard University. This actually shows you, this slide discusses the concept of a drop in productivity and cognitive activities by the people in offices that are exposed to the sick building syndrome and are having problems with that. The important thing to notice over here is that when the air ventilation and the air exchange rate has been increased, there has been a remarkable improvement in the people's perception and the productivity has actually gone up. So this actually is linking the productivity directly towards the ventilation and better air quality. The second thing I wanted to point out was that major concern is the air quality inside schools. Children happen to be the most vulnerable population because they actually are breathing in at a much faster rate than the normal or adult human beings because their intake capacity of their lungs is quite low. So that is why they are counted as the vulnerable populations, and it has been found in most studies that the air quality inside schools is not meeting the mark. In a study that we had done in schools in IIT, within IIT and in several other locations in Kanpur as well, we found surprisingly that the air quality inside the schools that were having natural ventilation was better than the schools that were there in the city and were actually having air-conditioned classrooms. We actually also found that the levels of the different pollutants, especially your pollutants related to vehicular pollution, to vehicular emissions, primarily your NO2, was slightly on the higher side in the schools in those areas. So research and the papers are being conducted on that, but this is actually being pointed out. Then the other thing I would like to cover first is that the students' academic achievements, they have been found to be impacted by inadequate air ventilation inside the rooms. Here also, in a particular study that is listed over here by Barboki et al., this came out recently, and this is, they're based in Netherlands, I believe. They have found that if you are increasing the airflow rate by say up to 2 liters per second per person, 2 to 10, you actually are seeing a significant improvement in the performance of the students in their class activities. So by this, if we compare in the Indian conditions, where in small schools, especially your government schools or whatever, the classrooms are small and their classrooms are now overloaded with students. The air exchange per person, the available air per person in the room might be much below at least the prescribed limits, and the increase in the air ventilation air availability needs to be looked into in more detail. Then moving on, continuing with the concept of the disease transmission, as Dr. Prashant has already explained very well. I'll not take time on this, but just to say that research has been conducted for the almost past 2 decades now, and this actually shows that there's a strong correlation between the association between the ventilation rate and the air movement in buildings and the transmission or the spread of infections, primarily of viruses and the other SARS cases as well. So this needs to be looked into very, very strictly or very, very carefully to be ensuring that the ventilation is properly maintained. So coming to towards the end of my presentation, next couple of slides more, I would just like to point out that we have seen that air ventilation is a big aspect of to maintain a good indoor air quality. So the next question would be, so what next? Where are we heading next? What I understand, we are heading or already a part of the healthy buildings movement. By this healthy building movements, you mean it refers to the emerging area of interest that practically means that the physical, psychological, as well as the social health of the people inside the building has to be maintained. And the next question on the slide is why COVID-19 raises the stakes for healthy buildings. Well, it raises the stake because people are now realizing more and more that they're not aware of what kind of environment they are spending 80% of their time. There has been reports to be stating that the people are going to be focusing a lot more on the air quality and the environmental quality per se of the areas where they are spending their time. I was listening to a webinar a few weeks back, and there they were mentioning that the concept of having a healthy building certificate that might be the reality in the not too distant future. A few of you might be interested in looking at this article. I just saw it this morning. This happened in Forbes, and the link is provided on the slide. These are general reasons that actually are leading towards the increase in the healthy buildings movement. And among the major reasons is that there is a push towards the towards the urbanization of the human population. They are predicting that by the year 2035 or 2040, roughly 70% of the world's population will be living in urban areas. When you move into the urban areas, the land area will not increase. You'll be having more of the vertical development of the building structures, and therefore the availability of area inside the houses to be ensuring that and the proper ventilation and the air exchange rate is maintained. That is going to be a big challenge. All the other points are listed, but since I'm running out of time, I'm not going to do that, and we move on to the next slide. It is also important to see that the healthy building movement will also be supporting the achievement of several of the sustainability development goals that have been outlined by the UN. India is a signatory of the Sustainability Development Goals movement, and several of the goals can be met if we are ensuring that we have green buildings and we have healthy buildings in our country and worldwide, of course. The next question that comes is, you're talking about green buildings and healthy buildings. Well, are actually green buildings really healthy as well? And the answer to that question is yes, because they are actually leading towards the availability of more daylight, which can improve the productivity of the people as a whole. And the green buildings can use more of the natural ventilation also. Sorry. Before I end, this is among my second last slide. I would just like to point out one thing that we have discussed so far, that increasing ventilation is important. It actually will lead to more, hopefully more better healthy buildings, more green buildings. But you have to keep in mind that ventilation improvement is not enough. If you improve ventilation, you are not necessarily converting your house or your office into a healthy building. Why? Because you are assuming that the air that you are bringing in is actually clean. It might not be. As I had been pointing out earlier, and as had been pointed out by Dr. Prashant Kumar in his talk as well, that the outdoors, the pollutant levels have been on the rise. So that has to be taken into account. The other thing is that one of the processes that can be attached along with the increased ventilation is improved filtration of the air that you are breathing in. And therein comes in the concept of the different air purifiers that are now available in the market. I'm not advertising any of them, but just stating that looking into this field might not be a bad idea if you want to be ensuring the development of more healthy. Then what should we do? Well, what should we do? We should actually be improving the air exchange, and we have to be increasing the runs and run the fans in your buildings. Why are you running the fans? And the people are proposing more and more to not use that much of AC, because with the movement of fans, you are providing a physical movement of the air, and there is more mixing, and you are pulling in the air from somewhere and throwing out the air somewhere else. That is probably a good idea. Then, secondly, you must think that it is a good healthy building is not nice to have, it is a must. And I believe that because of the situations that we are having under COVID, I think this is becoming more and more a reality in everyone's mind. Of course, it is also multiple strategies that can be employed towards bringing about a control of the situation. And this is my last slide. I really like this small quote I read from Florence Nightingale, and it shows from this that right at the very beginning, maybe 100, 200 years ago, she was able to realize that bringing in the clean air is a much better option, and to be helping people maintain and rejuvenate their health in a much better situation. With that, I take this opportunity to thank you all for your patience and your time. I have run slightly overboard than the time I was allotted, so I apologize for that, and I'll be happy to answer any questions. Thank you all very much, and thanks again to the SIE team for giving me this opportunity.
Thank you so much, Dr. Anubha Goyal, for highlighting the issues of indoor air quality, which is very important in current situation, as because of the COVID-19, we all are keeping ourselves indoors, and we are spending maximum of our time inside our house from last 3 months. Everybody needs to see the ventilation systems, either in mechanical or natural, and it should be properly ventilated. You also highlighted the international indoor air quality guidelines, indoor sources, and thermal comfort parameters, which also affect the health and working efficiency. It was also interesting to hear about the various symptoms which the occupants feel because of the situation, and how carbon dioxide, elevated levels of carbon dioxide affects the performance of students in schools. So thank you so much, ma'am, for highlighting all these issues. And now we have a number of questions from our audiences, and I'll try to take a turn before all the so first question which we have is from Mr. Divyan Sharma, and he has a question from Dr. Prashant. He wants to know how the rainy season is going to affect the spread of COVID-19. Am I audible?
Yeah. Yeah, that's a interesting question actually. To be very honest, there is no evidence so far that the any kind of the environment is going to change the spread of the COVID, because the fact is that it's not something which is roaming around outside; it's within our bodies. So I mean, there has been some hypotheses, or people have been saying that during the summers, when the temperature is high, then this will not go, this will spread less. But the fact is that it's been spreading actually all over the world in a very different environment. So it has got the capacity of surviving into very different the kind of environment. So I can only see from the indirect perspective that when you have rain, then some of the external surfaces might be washed off. So that might benefit actually from that kind of situation. But at the same time, it might also actually allow the other routes of contamination to become more active, because the water it works kind of as a lubricant. So to be very honest, I really don't have the clear answer to this question. And if I say something without the evidence, it will be just be kind of extrapolating or kind of making of my own stories.
Yeah, thank you so much, sir, for enlightening us with your views on how the how COVID-19 can survive in different temperatures. Now we have another very interesting question from Siddharth Arora, and he wants to know the precise recommendations on the measures that can be taken up in the built up in areas, because that's throwing a biggest challenge.
Yeah, I mean, I think that there is not one basically. So there is a suite of the recommendations or the suggestions which could be followed. So I think the first and foremost actually is the nature of the novel coronavirus is that if people come in contact, then it is spread. So the social distancing is definitely something which is important. And that becomes important in indoor environments as well. So no matter how good your ventilation is, but if the people are close to each other and they are kind of touching or kind of infecting through the coughing or sneezing each other, they will get infected. So as a first rule, I think the minimum social distance that needs to be maintained. The other thing is then keeping the quantity of the people to a level where the spread can be contained in those environment is important. For example, if you take a train coach or you take a bus coach, actually, if it's full with the people, there is no way actually that you can stop the spread even if you properly ventilate it. Now, the next thing is the ventilation. The ventilation is, I think, in the environmental conditions, when you got an opportunity for naturally ventilated, then definitely this should be a strategy to use. But then in some cases it becomes quite challenging. For example, if let's say there is a quite the severe weather, for example, if you got high temperature, ambient temperature, or you got very low temperature, in those situations that doesn't work. So one of the things is then avoiding actually the recirculation, because the recirculation of the air, that means that you are having the same infected air being being used for breathing all the time, but also thinking of the filtering system which is placed in the mechanical ventilation, because sometimes what happens is these things are being put in place and they're never maintained. So you can say for saying that there is a mechanical ventilation is placed, but that's not really doing the job what it should be doing. So I think sometimes these small things can make a huge difference in these situations. So as I say, I think there are multi kind of prone approach actually, which is required even to contain actually the spread in the indoor environments.
Yeah, thank you so much, sir. So there is another very relevant question by Dr. Radha Goyal, and she wants to know that as there is very high use of disinfectants in the like sodium hydrochloride solutions to sanitize commercial spaces, hospitals, schools, institutes. So do you think that this will create some kind of an impact on atmospheric chemistry in terms of generating some other reactive pollutants, which could be very dangerous to human health? So We need to
So, yeah, that's a really interesting question, actually. But one thing we all know that excess of everything is bad, right? So we can eliminate one problem, but then you can generate another one. So usually the spirit-based kind of, the disinfectant, like you use the hand sanitizers and so on. They are effective and they have a less kind of side effects in terms of because they evaporate actually after doing their job. So the job is like you need to kill the bacteria on a surface and then disappear. But the one you're talking about looks to me that they don't really have a high kind of, the evaporation kind of thing. So it might leave actually the chemical contents on the surface, and that may actually, if used in excess, could contribute to the indoor chemistry. Like you got already the VOCs in there, you got the pollutants in there. So you cannot really deny actually, the possibility of that. But now the question is that to what level it's been used, to how much the other sources are operational in those things. What is the ventilation situation there? So all this will dictate actually the level of the intensity of the chemistry and its effect actually onto the indoor air quality. The smell could be one of the things for sure, which could be seen actually when you're using this kind of thing. And if it is in excess, then the odor becomes a problem in one case.
Yeah, you very aptly summarized, sir, that excess of everything is bad for health. So now we have another very interesting and important question from Dr. Radha Goyal, and she has this question from Dr. Anubha, and she looks forward to what kind of she wants to know that what kind of impact of various building materials will have on the ventilation and particularly on the overall indoor air quality of the buildings. Dr. Anubha,
I cannot hear you.
Okay, ma'am, there is a question for you from Dr. Radha Goyal, and she wants to know that what kind of an impact of various buildings is there on buildings on the ventilation and the overall indoor air quality of the building, impact of the building materials on ventilation.
That's a very important point, because depending upon the building material that is being used, if the material has a lot of stuff that can actually be volatilized, so in the higher temperature ranges, the emissions of those compounds will increase. That might be happening more in the use of more synthetic materials that are being used. In the traditional ones, the situation would not be that bad. But in the new buildings being made with pre-made material being put together, research is being, I'm sure, is being conducted to see that what are the emissions of different pollutants from those materials. Primarily, as of now, that is being focused quite a bit is actually the emissions of formaldehydes from the use of different kinds of paints. They are quite toxic, and the levels can be quite high, right up to 50 to 20 days after the material has been used on the different wall paintings and materials like that. The another important thing to notice is that if the buildings are being placed too close to each other, which is happening more and more in the urban areas now, the distance between two buildings should be roughly twice the height of the tallest building. Otherwise, there is going to be a lot of blockage to the flow of air between the buildings, and that is going to be leading towards more of your not a proper ventilation of the air between the buildings per se. And the air quality inside those two buildings is not going to be very good.
Thank you, ma'am. We have another question for you from Mr. Shreyansh Kumar, and he wants to know that, is there any standard or parameter for ventilation and air quality index in molecular or biotechnology or microbiology or other such labs, and what are those parameters?
I think there is. There are what I had showed you was a snippet of the ventilation conditions that are ventilation requirements for the most frequented microenvironments from your NBC and even your CBC, California Building Code. They have and even your ASHRAE, they have very big codes available that are outlining the ACH value for the different microenvironments, including the lab spaces. I do not know for sure whether they have for specific labs like biotech labs or whatever, but definitely for your lab spaces and schools and stuff, they have those ventilation codes available. You might want to check up on the ASTM codes, ASHRAE codes online. They probably have, they definitely have those codes available, and you can be looking up for values. I hope that answers your question.
Yeah, you very well answered it, ma'am. Then I also have one little, inquisitive mind, and I want to know that what kind of impact COVID-19 have on children's cognitive development, as most of them are keeping indoors all the time, and it is very difficult. It's a difficult time for children, and you know that it is very difficult to keep them indoors in the confined spaces. So, what kind of an impact this COVID-19 lockdown will have on the cognitive development of children?
To answer your question, I'll say that there has research been coming out that is actually showing that because of the inhalation of too much fine particles, there are reports stating that it is having an impact on children's cognitive behavior, and that is having impact on the females who are actually pregnant. That is impacting the child even before it is born. So there definitely is a cognitive impact of the occurrence of pollutants indoors. In this coming time, since the children are spending roughly most of their time indoors anyways, they are being exposed to much more pollutants. Second thing is that this might be a little bit of a digression from what you are asking me, but most of the people are spending most of their time in front of either computers or laptops or phones. More and more children are coming in contact with these materials, and they emit radioactive rays that are not good for the children's development and their cognitive capabilities also. So because of that, there might be a negative impact on the children's health as well as their cognitive capabilities eventually. I'm not an expert in this field, so I cannot be answering your question with full details, but this is what I feel is the situation.
Thank you so much, ma'am. You very aptly solved my question. Now, there is another question from both Professor Prashant and Professor Anubha, and this is from Mr. Rajiv Pradi, and he wants to know that that in buildings with centralized AC ducts, what measures should be taken to prevent the spread of COVID-19 positive cases if it is found in any other part of the building? And should some filters be installed at the duct opening?
I'll say that as what is my understanding is that they are suggesting that do not use the centralized AC as much as possible. But if that is being used, definitely there has to be a proper cleaning of the system that needs to be done. Because what happens is if there is a virus that gets inside the AC system, it is getting a very conducive atmosphere there, low temperature, and also humidity would be slightly higher for them to grow and multiply. So if the central AC is being used at a location, definitely the cleaning should be done properly, and definitely more filtration mechanisms should be used to ensure that the air that is getting to you and you are breathing in is actually cleaner than what is being circulated in the entire building by itself.
Yeah, just to add actually, so the thing is that it's not really possible from the practical point of view to kind of reinstall the whole the infrastructure. So
yeah, I agree with that. Yeah.
So I think the point is that we have to work with what we have to hand, and the key issues actually remains is whether the system is doing the job for which it was originally installed. And one of the things which, as Ava said, is that it's very important to have the regular cleaning, but also understanding whether the filters actually are of the right grade. So one could also think of reviewing the strategy in terms of whether these are the right set of filters being used, and also because these these air conditioning systems allow you to play around with the flow rates. So depending on where this air is coming and how big those rooms are and so on, I think another strategy could also be reviewing actually the situation with the how much is the air going in and how much is going out, and perhaps the tweaking to those flow adjustments. And this is pretty much doable. It just needs a little bit of attention.
Thank you, sir, for answering this question. We have few more questions, and if the speakers are not tired, I'd like to take them up.
Yeah, please go ahead. Yeah.
Sure, go ahead.
So there is another question from Dr. Radha, and she wants to know that if there should be different air exchange rate guidelines for the different buildings, like new buildings or refurbished buildings or old buildings, and what should be the ideal gap between the two buildings in order to check the spread of the virus.
So firstly, there are already established guidelines actually for the air ventilation. So that's done by the SRA, and there are some the other guidance document there. So there is, because this area is not really new of the indoor air. It's been there for very, very long time. So, but what is more important in this particular case is that how effective those guidelines could be to contain the spread. And that requires actually a much more, the customized kind of, the information for those particular buildings where you wanted to apply actually, those guidance. So, and you need to then put actually some extra caution on top of the guidance. For example, the ventilation you can maintain, but then again, I'm going back to the original thing that if you've got too many people in there, it's not gonna, influence actually the spread. It might improve the air quality in that particular room, but not the spread. So I think there is no kind of the one single rule that you follow this guidance and then this will work. The thing is that one has to look at what's the ventilation in that particular setting, and how many people are there. What is the distancing, the social distancing, between those people while they are working. So if you see in Europe, a lot of these schools are open. They reduced actually the capacity to 1/3, or in some cases 1/4, where there are only the few children sitting in a classroom. And this strategy is also considering the fact that they wanted to make sure that the distancing is there alongside the ventilation. So I think this is my kind of the short answer to the first question. Related to the gap between the two buildings, I'm really not sure actually whether you can link it with the COVID spread. The fact is that it all depends again on the people, and the gap between the two buildings that can only allow actually the affect some certain natural ventilation. If let's say those buildings are naturally ventilated, in that case that might affect the ventilation, but that could affect the ventilation in both ways. Sometimes if the buildings are placed in such a way that it is acting as a funnel, so in fact it could increase the airflow into that gap and can affect actually positively the natural ventilation. But if these buildings are one after another, then what you are expecting in that particular case is that there is a wake of one building onto another, and there might be an interesting situation where you got let's say an hospital where you got the COVID, these people, and then you got a building which is very next to each, next to that hospital. And if the air, from the hospital somehow is ventilated into that building, then it becomes a big problem. So in terms of the spread, I think there is, I can't see a direct correlation between the gap between two buildings, but I could see a consequence actually if a building is falling next to a contaminated building and the flow is going in that particular direction. Sorry if I didn't answer the question properly.
No, that
I would like to add something here. From what Dr. Prashant just said, this pretty much implies also that the met conditions of the location where the buildings are being constructed will have a big role to play in deciding what the safe or acceptable distance between the buildings might be. It will also depend upon the buildings that you're talking about, what are the floor levels you have. If you have only single floor, multiple floor, or whatever, that also will have a significant. Thank you.
Thank you so much, ma'am. Thank you, sir, for addressing these questions, and I hope I was able to take in the chat window. And if there are any participants who would like to ask their questions directly to the speakers, they are most welcome. Okay, so I think all the questions are being addressed by our speakers, and I would like to invite now Dr. Sunil to propose a vote of thanks for our speakers.
Thank you, Pratima. Uh, Dear speakers, participant, and my dear colleagues, it's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of Society for Indoor Environment, and on my own behalf, extend a very hearty thanks to both the speakers for sharing with us their experience and opinions about this important and timely topic in view of the current situation of COVID-19. I must mention our deep sense of appreciation for our first speaker, Professor Prashant Kumar, founding director of Global Center for Clean Air Research, University of Surrey, UK, who get time from his busy schedule to present in the seminar early in the morning as per UK timing and presenting a wonderful talk on COVID-19 aerosol and air pollution. Thank you so much, sir, for such an informative lecture. And we will also look your new articles on the impact of lockdown, which you have mentioned. Thank you again, sir, for such a wonderful lecture. Now, I would like to express our sincere thanks to Dr. Anubha Goyal, Associate Professor, IIT Kanpur, for giving an excellent coverage on role of ventilation in indoor microenvironment, which is a key parameter to maintain better indoor air quality in buildings. We are, we are all inspired by your great words. Thank you, ma'am. Now, I would like to thank you, our moderator, and my dear friend, Dr. Suman Chintala, for moderating the session very nicely and connected speakers and participants throughout the session. I would also like to thank our convener, Dr. Pratima Singh, for all arrangement and introducing us with the speakers and connecting the participant and speakers during the sessions, during the questions and answers. Thank you, Pratima. I am pleased to announce the fourth webinar on 24th June, 27th June, on Saturday around the same time. We will release the information soon. Please keep an eye on our social media web page and SIE website. Last but not the least, I would like to thank you whole Society for Indoor Environment webinar organizing team for organizing such a wonderful webinar. Thanks again to all the participants for attending the webinar. Thank you all. See you on 27th June. I hope we have all satisfied with the question and answer and the lectures. So we are now closing and thank you.
It's
I
pleasure.
would
Yeah.
like to take this opportunity to thanks once again the listeners and the participants of this webinar, as well as the organizing team for SIE. It has been a pleasure to be sharing my thoughts on the issue of air pollution in today's session. And thanks a lot to Dr. Prashant Kumar also. It was very nice to be listening to your talk, sir. And I look forward to communicating with you sometime soon.
Yeah. Thank you, ma'am. Thank you so much, sir.
Okay, thank you. Thank you,
So
everyone.